This question provides another opportunity to practice a nice systematic approach to an expected value problem. And I recognize this as an expected value problem because the question at the end of this long description is find the resort's expected yearly profit. So what we want to do is identify what the outcomes are and what each of the probabilities that goes along with those outcomes is. The outcomes are, well, if in a season with more than 75 inches of snow, it makes $250,000. So there's one numeric outcome, a profit of $250,000. If snow falls between 40 and 75 inches, the average profit is 160. So there's a second potential outcome, a profit of 160,000. But if the snow falls less than 40 inches, then they will lose $70,000. And so our third and final outcome is negative $70,000. Now we want to find the probability for each of those outcomes. Well, let's see. The resort gets over 75 inches of snow 40% of years. Well, more than 75 inches of snow goes along with the outcome of plus $250,000. And since that happens 40% of the time, there's a 0.4 probability of that happening. The outcome of positive 160,000 was snowfall between 40 and 75 inches, and we're told that happens in 45% of the years, which would give me a probability of 0.45. The loss happens if snow falls less than 40 inches, which I'm told happens in 15% of years, giving me a probability of 0.15. Now I'm all set up for my expected value computation, where I take each numeric outcome and multiply by its probability. So I get 250,000 times 0.4 plus 160,000 times 0.45 plus negative 70,000 times 0.15. Now it's an arithmetic problem, and after crunching the numbers, I find that the expected value, meaning the resort's expected yearly profit, is $161,500.